So I want to talk about technical debt, which isn't always a bad thing. What it is when you take shortcuts to move faster now, knowing it'll slow you down later. So if you've ever been coding and you're like, I'll fix this later, I'll refactor this later, well, you've just taken on technical debt, of which there are four main types. This is Martin Fowler's 4 quadrants for technical debt. Deliberate and prudent, which is we must ship now and we'll deal with the consequences later. So that's a strategic business decision. Then there's deliberate and reckless, which is we don't have time for design, which is dangerous, but still a conscious choice. Again, it's deliberate. Then there's inadvertent and prudent, which is now we know how we should have done it. And you're learning more about technical debt. And then there's what maybe most of us do, inadvertent and reckless. What's layering? It just shows a lack of skills and awareness. And y'all know how much I love my analogies. Technical debt is like financial debt, like a business loan, for example, where you borrow money that future you has to pay back. In tech debt, you borrow time that future you has to pay back. And just like how you pay interest on a loan, you also pay interest on tech debt every single time you touch that code. The interest is all of that extra time working around it, debugging it, or just being slowed down by it. And something I've discovered and come across is that a lot of teams don't even realize why things are taking so much longer than they're supposed to or that they did before, when the answer is because of all of this accumulated technical debt. Now, in doing some research, I found that teams on average will spend anywhere between 23 and 42% of their time dealing with technical debt, which also slows down development velocity by about the same percentage, 20 to 40%. That seems to be the magic number because IT budgets are also allocated about 20-40% of it to addressing technical debt, and the cost of fixing this debt increases exponentially over time if left unaddressed. It's compounding interest, just like my loan analogy. So how do we handle technical debt? Well, there are a handful of ways to do it. One of the most popular ways is spending 20% of your time each sprint allocated towards tackling technical debt. That includes maintenance as well. So for every 5 days, every week, you're spending 1 day per week split up however you wish. What this does is allows you to maintain feature velocity, which is just the rate at which a team delivers new features of their product, and preventing debt from accumulating. That's what's known as the 80-20 rule. 80% of time and resources should be spent on new features and technologies, while 20% should be allocated to reducing or managing technical debt. And I did only find this article while I was doing more and more research in technical debt, because I obviously know about technical debt, but I want to bring you statistics and the facts and other people's opinions as well. And this is actually a blog from the sponsor of this portion of the video, Monday.com, which is a beautiful way to be able to manage your technical debt. And Monday.com just released a new feature called MondayMagic.ai that they wanted me to share with you, and that'll make this process, the setup of it, a whole lot easier. Because instead of building it out manually, I can just describe what I want to Monday Magic and have it build it for me. So create a tech debt management workflow with refactoring priorities, code review tracking, dependency updates, and technical improvement tasks, or whatever you need that you got out of this video. So we're just going to click create with Monday Magic and let it do its thing. And there we have it, actually pretty solid. We have a tech debt management system with refactoring, project manager dashboard, tech debt with tech debt items based on severity, impact, estimated effort, and priority score over here. But wait, I also see an onboarding video for you.
Welcome to your tech debt management system solution, Magic built for you.
Okay, so it's not perfect. It didn't really fill out the forms and the voice is a little off, but if they can actually prepare a solid onboarding video for what is generated, that would be nice. And of course, if you want to make any adjustments, you just ask Magic for more changes, whatever you want. And then I guess now we come up here and create a solution. And now your solution is ready to go. It's all set and waiting for you on Monday.com, fully built. Now, Monday Magic is in early access right now, and you can try it yourself by using the link in the top of the description. That lets them know I sent you. And of course, you can set up anything within Monday.com with Monday Magic I just used this example since we're discussing tech debt. Speaking of which, let's get back to it. But other teams, like at Shopify, don't think 20% is enough, so they have the 25% rule. So they allocate 10 of that 25% for daily debt. This is making the code we're working in better, and it totals to 4 hours per week. The idea here is to encourage the practice of refactoring into the team ethos and culture. And this 10% is on code that they're already working on in our regular daily work. It's not going searching for random bad code to fix. So they're not hopping into Sonar Cube and looking at all of the code smells. It's the friction that they face when implementing new features and saying, okay, I am allowed and encouraged, as they say, to go in, refactor some of this code so that next time I don't hit the same friction. And then 10% for weekly debt. This is something that they actually plan for and that they put items on their project boards that can be worked on. And this could be split among the team equally, 4 hours for each of a team of 4, being 16 hours in total, or just one team member working on a card for 2 or over 2 days, doing the whole 16 hours themselves. And then the 5% for monthly and yearly debt, which is 2 hour-long meetings a week somewhere to talk about planning and really addressing those bigger problems and seeing if they need to be made a priority. So yeah, that one's a little bit up in the air. It's not as concrete as 20% every single sprint, or not as concrete as the next one being dedicate one entire sprint every 6 to 8 weeks. And that's assuming a 1 week long sprint. So 6 to 8 sprints that are feature focused, and then one sprint that is technical improvement, technical debt, and maintenance focused. So that's the big picture of where do we find the time. Now, how to actually implement this. First, I don't know if you want to hear it or not, test-driven development. This is personally something I don't like doing, but I've been wrong before. Well, I thought I was wrong before, but I was just mistaken. Test-driven development is where you write tests first to prevent poorly designed code from entering the system. So while this isn't actually managing technical debt, I just realized this was in the way of the camera and I have food and drink now. It is preventing technical debt, preventing that bad code from getting in the system in the first place, or at least slowing it down. Because with test-driven development, it's kind of difficult to write messy, tangly code when you have, or at least logic, when you have to pass a clean test first. And then there's pair programming. Because when you have 2 people looking at the same code, implementing the same code together, it makes it a whole lot more difficult to take dumb shortcuts, because one of y'all will be like, oh, well, yeah, let's just hack something together and put it in like that. And the other's like, wait, really? We're going to do it like that? Let's build it right. Or maybe you're just too self-conscious to write bad code in the first place when somebody else is looking over your shoulder. Pair programming for preventing tech debt, I feel like is just so underrated. And then there's stuff that you can automate, like having a CI/CD pipeline with quality gates, because you can automate static analysis, test coverage checks, linting rules, and don't just think your AI is going to handle all of this for you. But AI can help in some instances, of course. But all of this stops that, for lack of a better term, garbage code from hitting, well, even the development server, but particularly production. Because I do not care if you have CI/CD with quality gates directly to production, do not push to production. You have a development server and a testing server for a reason. Use them. But then, of course, design patterns. If you haven't watched my video on design patterns, I highly recommend it. I may be a little bit biased, but you don't need to over-engineer these things. Every class doesn't need to be like a gang of 4 diagram. But using consistent architecture makes your whole code base just easier to understand and maintain. It's less of like, what the heck is this code doing moments, because there's less debt. And then there's the Boy Scout rule. But I need to be a good Boy Scout and eat my food. I'll be right back. The Boy Scout rule in this context is leave the code cleaner than you found it. Cheesy maybe, but it works. And it doesn't mean like rewrite everything. It means if you see a variable name that is not that great, rename it. You see some dead code, delete it so that you don't experience a $462 million loss like Knight Capital. but just all of those little things because it compounds in both ways. And then where you have TDD and the Boy Scout rule merge is red, green, refactor. Whereas red is that you write tests that fail on purpose, not how you normally write them. But you do this because, well, the code doesn't exist yet. Green is you write just enough code to pass the test. Nothing perfect, just functional. And then you refactor. You clean it all up. You name things better, you remove duplication, you split methods, all of the stuff that you usually skip because you don't have time. It may not be as exciting as, oh, well, the code works, let me just ship it and move on to the next feature, next task, but it's what's going to allow you to be able to move faster from feature to feature, from task to task a week from now, or a month from now, or a year from now. Because if you don't refactor all this, you accumulate tech debt, and it takes everything a whole lot longer to complete, is what I'm getting at. But how do you measure technical debt? There are a handful of methodologies. They actually quantify what kind of mess you're in. And let's talk about one of the more structured approaches, the scale method or SQALE method. I don't know. I've only ever seen it written down. SQALE, as well as the debt ratio formula, which is technical debt ratio equals remediation cost divided by development cost. What the heck does that mean? Basically, how much time or money or both would it take to fix the mess? That's remediation costs divided by how much time or money it took to build the thing in the first place. That is the development cost. So if it were to cost $100,000 to fix the debt in a $500,000 system, that's a 20% debt ratio. And here's what the numbers mean, because you'll see this formula used in whatever dev tool. It'll probably be SonarQube. Inside SonarQube, you will see the percentage. Under 5%, you're good. That's where you want to stay. 5 to 10%, you're still good, but keep an eye on it. Over 10%, so like 10 to 20%, that's all right. You're treading dangerously here. This is moderate risk where it starts to hurt development velocity. And then over 20%, that's just not good. You can't ship anything whatsoever without fighting your code base every step of the way. And when taking down this percentage, you want to focus on what is most important, what is most impactful. There's a 3-factor model that I remember learning about, but I can't seem to find too much information on it. Maybe I'm just looking in the wrong spaces. It's a triangle model, or like a 3-factor model to assess debt. So 1, you have impact. How badly is this slowing us down? Number 2, you have fixed cost. How hard is it to fix? And then number 3, you have spread. How much of the code base is infected? And of course, you want to prioritize the stuff that is high impact, not too hard to fix, so you're being at least a little efficient here. And you want to tackle stuff that spreads like a virus. If it hits those 3 things, well, that's a bit of a nightmare, so you want to tackle it first. And then there are other points of tracking your debt, not just the overall ratio, but you also have a cyclomatic complexity, which is just a fancy way of saying how many decision branches are in your code. More branches equals harder to maintain. Then you also have test coverage. Not just do we have tests, but how much of your logic is actually protected and tested. Then you have lead time, how long from I committed code to it's in production. Because if you notice over time that time continues to grow and get longer and longer from committing code to production, well, it may be tech debt clogging your pipeline. This is kind of where people get lost because it gradually happens over time. They kind of don't notice it, but if they are able to look back and they track this information, you're like, wow, this type of feature, what have you, used to take us 2 days. Now it's taking us a week. Then you have to start addressing it. And then good old code churn. So if the same file keeps changing every single week, something's wrong and you need to take a closer look. And another way this is looked at is another type of 80-20 rule, whereas 80% of your pain is probably from 20% of your files. It's also known as the Pareto principle, apparently, which I never knew, but I discovered. I don't think it's a software term, but it definitely applies in software. So again, like that 3-factor or triangle method, don't refactor everything. The idea isn't to just completely eliminate technical debt, it's to be smart about it. Hunt for the hot spots. Prioritize where that fire is. And if you aren't overwhelmed enough by all of these different methodologies, let me tell you about the PAID model. This part shouldn't overwhelm you. It is dead simple. PAID, acronym, performance impact. Is this making the app slow? Architectural importance. Is this core to the system or just some fringe feature? Integration complexity. Is this thing tied to 10 other systems? And then dependency. Will changing this break a bunch of stuff? Stack those up and you'll know exactly where to start. Combine that with the 80-20 rule, the new one, and then everything else that we talked about. And now you've kind of got a roadmap in order to tackle this. So once you identify and prioritize the 20% that is giving you the 80% of the headache, you gotta figure out, how do we clean this up? Do we refactor it or do we completely rewrite it? And yes, there's another 2x2 matrix for this. You can't escape them no matter how hard you try. You have high business value plus low technical risk equals refactor. High business value but high technical risk, rewrite. Low business value plus low technical risk is live with it, and low business value and high technical risk is deprecate it. And I already briefly mentioned tools and automation where you have SonarQube. That's the one that I always use. I haven't used the other two that you see on screen right now, Code Climate and Code Scene, but they all have their different niches that they fit into and that they hit. So research some of those and compare them to see which is best for you. But then there's also the integration workflows. You can have gate deployments on quality thresholds. You can have automated debt tracking and project management tools like Monday.com. That's okay. I wasn't going to mention them again, but I mean, if the shoe fits. Monday.com is a really cool tool and a really cool team that I enjoy working with. So then you have your communication. So like notifications via Slack or Teams for debt accumulation, and then your dashboard reporting for stakeholders. If you're a solo dev, I don't know if you have to focus on all of that, but I feel like a lot of software engineers, team leads, what have you, are going to be watching this video. So there's that flow chart. And you have real-time tracking. Not only are these tools hooked up to your code base, so it is all real-time, but you can also have alerts set up when the debt ratio exceeds the thresholds, whatever thresholds that you set. You can also track velocity impact metrics like we were talking about before, where you have the development velocity slow down over time. And then, of course, maintain debt inventory in your backlog. I feel like that's the most obvious one. Did I say shareholder earlier in the video? I really meant stakeholder, which is somebody who actually has an interest in the company's success. I guess a shareholder does, but they have no, way to act on it. I clarify this because when you're talking to a stakeholder, I would actually highly recommend, if they don't understand technical debt at all, to use my financial debt analogy that I used previously. But also you want to talk to them just like you're filling out a resume. You want data, numbers, time estimates with debt impact. So for example, this authentication system, because we have some tech debt involved with it, adds 2 days to every user story involving login, or our deployment process debt causes 30% of our production incidents, that type of stuff. So if you want a full framework, you can see it on screen here, which is the current state, what debt exists and its measurable impact, like we were just talking about, business risk, what happens if we don't address it, investment required, which is time and resources needed, expected ROI on said investment, increased velocity and reduced incidents, which this is, how it's been taking us a week to complete these features. Now we can do them in 2 days because we don't have to work around all of this technical debt or any of the incidents, as I mentioned, that are occurring due to technical debt. Like if you really want to scare them, use the Knight Capital example, or there are plenty of other ones. And then your timeline. So just your phased approach with milestones so they can get a clear picture of estimates, just like you do on regular coding tasks. And I have more information like real world results, which are like metrics before and after of companies who have tackled the technical debt and how they did it, and performance improvements and failure examples and transformation metrics. And one of the actual failure examples is how like a company rewrote an entire system instead of targeted refactoring, which meant they spent 18 months adding no features. So sure, they have no technical debt now, but you just stagnated for a year and a half. That's why you got to weigh all your options and do targeted refactoring like we previously discussed. So what to take away from this video if you really want to kind of sum it up, because I know I threw a lot of information at you, in order to actually have something actionable, putting together an implementation roadmap. So first, install the measurement tool and allow it to tell you what tech debt you have in your code base. Then you want to identify, just start with 5 debt hotspots. Calculate the current debt ratio and just establish the baseline metrics. You want this full picture of what is going on, the tech debt in your code base. That's phase 1. If we want to talk about a phased roadmap. Phase 2, that would be to fix the low-hanging fruit. What isn't that difficult to tackle, but out of those that are easy to tackle, that are the most impactful. And while you're doing that, you also want to implement those prevention practices we discussed earlier so that you're not accumulating more unnecessary tech debt that is like this low-hanging fruit that can easily be done when you're implementing a feature or when you come in contact with it. This is also where you'll set up that automated tracking, whether that be alerts when your debt ratio hits a certain percentage or any other sort of metric that is in your tool base, like SonarQube or what have you. And then implement one of these, whatever you feel is best for an allocation framework. That's your 80-20 split, the 25% rule, the 1 sprint every 6 or so sprints that focus on just tech debt, which that is what I prefer. Have good prevention practices in place while just batching everything in one full sprint and just you and the rest of your team just tackle all the tech debt in that sprint. That's what I like to do. If I couldn't do that and I were to have another option, I would do the 20% rule, and I would do it in a way where it's just I focus 1 day a week on tech debt and that's it. I like to batch things. So if you like to kind of do the 25% rule that we previously discussed from Shopify, then you kind of, do an hour here and an hour there, and then you have more. That one, some of those principles are good, and you can carry those over, and they kind of play into more of the prevention type of idea. Encourage your developers, or if you're a developer, be encouraged to tackle technical debt and prevent it as you go, even if that means making a 2 to 3 hour task a 4-hour task, because it'll pay dividends in the long run. And once you choose that allocation framework, address the high impact debt items, establish regular review cycles, so like monthly debt reviews, and then track velocity improvements. So how long does it take a similar type of feature to go from commit, or even how long it takes to code it, but also goes from commit to production, and measure both of those aspects and see, hopefully, that it gets shorter. And then you'll be able to take all of this, create your slide presentation, whatever you do for your stakeholders, and report it to them quarterly or however y'all do it, and just continue with prevention practices, as well as create that culture, if you will, that Shopify said they encourage quality maintenance of taking some extra time to ensure unnecessary and unneeded or unwanted tech debt isn't accumulated. Because again, all tech debt is not necessarily bad. It just needs to be a conscious trade-off of we need to ship this feature, so we're okay with having a bit of tech debt go along with it if that means it takes 1 week instead of 2 weeks right now, because we know we'll take care of it during that sprint where we're going to tackle all the tech debt, you see? But if it's just silly tech debt, then it just doesn't make any sense. Tackle that when maintenance. And also, even though you have all of these things in place, have a full understanding that some of the incidents and problems that you're facing may be due to tech debt. If you see a rise in production incident rates, then that may be tech debt and you want to look closer. Or maybe you notice that developers are avoiding certain areas of the code base. Why? Tech debt, maybe. Probably. Increasing times for simple changes. New team members struggling with the code base. I made a video all about how to go in and learn a new code base and using a bunch of different tools and approaches to go about it. But if it's really, really difficult and you see them struggling more than maybe you feel is normal, or they struggle more than previous new team members, it may not be just them. It may be due to tech debt in the code base and the code base just being crazy. Every code base has technical debt. And the difference between high performing teams and struggling ones isn't the absence of debt. It's the discipline to manage it consciously. Again, your job isn't to eliminate it, spending 18 months with no features. It's to make sure that you are making a conscious trade-off of speed versus tech debt. It just needs to serve your goals instead of sabotaging them. And that is how you manage technical debt, or everything you need to know about technical debt. I don't know what I'm titling this video, but I hope you enjoyed it. Y'all have a good one.